Hello everyone. Assalamu alaikum. This is Mohammad Jahangir Hussain from MJ's Math Assist. Today we are going to solve a mechanics paper from Cambridge International AS and A level, February March 23, variant 42. So let's get into the question paper. Okay, this is the paper we are going to solve today from February March 23, variant 42, paper 4, mechanics. Without any delay, let's get into question number one. Okay, in question one, you see a crate of mass 200 kg is being pulled at a constant speed along horizontal ground by a horizontal rope attached to a winch. The winch is working at a constant rate of 4.5 kilowatt, and there is constant resistance to the motion of the crate of magnitude 600 meters. So let's present this information on a rough diagram. It's the crate, and it is pulled by a winch. You apply a forward force F, and F is equal to E by V, power by velocity. Now, there is a constant resistance of magnitude 600 Newton, and the crate has a mass of 200 kg. Okay. Now find the time it takes for the crate to move a distance 15 meters. Will move a distance of 15 meters. And you know it is moving with constant speed. So you have to calculate the time. Now first, let's find the V. Acceleration is zero because it is moving at constant speed. So P by V equals to R. P is 4,500. That's the power. You only have 4.5 kilowatts, so it is in watt 4,500 divided by V equal to V raised to. So V is 4,500 by 600, that is 7.5. The time it takes to travel a distance of 15 meters, 15 by V, so that's 3 seconds. So it is 7.5 meter per second. Okay? You can do it alternately, like work done by the force, work done by the driving force, winch equal to work against resistance, then R into 15. And work done by the driving force is P into T, P into T, also R into this distance, let's call it H. So R into so T is R into S by T. R is 600 into S is 15 and power is 4,500. That will also give you second. So both ways you can use one of the methods. That's part A. Now let's move on to part B. In part B, see the rope breaks after the crate has moved 15 meters and the time taken after the rope break for the first to come to rest. Now you see the velocity of the rope is 7.0 meters per second. So you have to find how far it moves against the resistance before coming to rest. Now when there is no forward force, then if you apply the Newton's second law after the rope breaks, we have minus resistance equal to NA. Mass is 200, so minus 600 equal to 200 A is minus 3 meter per second squared. Now, we need to find the time. So, U is now here is the important point. If you use the alternate method in part A to find the time, then you have to find V using this first method. Okay. Then you'll find the acceleration, then apply V equal to U plus AT. V is 0, U, the moment the rope breaks, the particle was moving. The crate was moving with the speed 7.5 meter per second. So initial velocity is 7.5 plus acceleration minus 3 into t. So t is 7.5 by 3. Oh, no, we are not going to find the time. We are going to find the time, yes. So t is 7.5 by 3. I think it is 2.5 seconds. Okay, that's 2.5 seconds. Part B of question number 1. That's it. Now let's move on to question number 2. In question 2, you see a particle is projected vertically upward from horizontal ground with a speed 15 meters per second. Now find the speed of P when it is 10 meters above the ground. Now let's present this on a rough diagram. Here from the ground we are projecting it vertically upward with speed 15 meters per second. What happens to its motion? It rises to its greater side, then returns back to the ground. Now, we have to find the speed of the particle at 10-meter height. Let's say 10 meters is here, 10 meters. You have to find the speed. Although it will be at 10-meter height twice, but in both cases the speed will be same. While ascending, speed is V, while descending, the speed is V as well, but it is downward. Okay, let's denote the starting point at A and its point which is 10 meters above the ground, above the starting point is B. So for this segment A, B, we know U, we know acceleration, we know the displacement. So we know U 15 meters per second, acceleration minus 10 meters per second square, and F, the distance displacement is 10 meters. We need to find V. So linking these four parameters, we have the formula V is equal to V square plus 2AF. Well, U is 15, A is minus 10, S is 10. So V is 5. V is 5 plus minus. And both, since we are calculating for the speed, so V is plus 5. Now, let's move on to the next part. At the same instant, he is projected a second particle Q is dropped from a height of 18 meters above the ground. In the same vertical line as P, find the height above the ground at which the two particles collide. Remember, we are dropping this particle at the same instant P is projected. P and second particle Q is dropped from a height of 18 meters. Q is dropped from the Q dropped initial velocity 0. So let's say they meet somewhere here. Okay. And by that time, the distance traveled by A is x meter upward and distance traveled by Q is y meter downward. So for the second part, let's say they meet 3 seconds after, say, let's say, collide 3 seconds after projection. Okay. One is projected, the other is dropped. Let's say 3 seconds after the projection. In this t-second, the distance traveled by t for t is moving up. It's ut plus half it is square. So s is denoted by x here. So 15 into t plus half into minus 10 into t square. That is 15t minus 5t square. And for q, remember, if P is projected up and Q is dropped, so Q is moving downward, so Q is equal to T plus half it is square if we apply. So S is Y, U is 0 into T, and acceleration for Q, since it is moving downward, acceleration is downward, it is positive T square. So Y equal to half T square. Now you see X plus Y, this distance traveled by is equal to 18. So 15t minus 50 square plus 50 square equal to 18. So t equal to 18 by 15, that's 1.2 seconds. And that's the time, but the question is asking for the height above the ground. The height above the ground will be the distance a particle t travels up, that is x. So substitute the value of t in x is 15 into 1.2 minus 5 into 1.2 square. That will be 10.8 meters. Okay, that's for the height at which the particles will height. Okay, is there any further part in this question? No. So let's move on to question number 3. In question 3, you see, a particle moves in a straight line starting from rest from point O, and the acceleration of the particle at time t second after leaving O is a meter per second square, where A is 4 times t to the power half. Okay? And remember, particle starts from there, from the point O. So, or from this one, we know that T0 at T0, V0, and starting point, if you consider O to V0 6 points, so S is 0. Now, the speed of the particle, you need to find the speed of the particle when t equal to 9. For that, you need to find the expression for v first, and we have acceleration, so to find acceleration in terms of t, to find v, you need to integrate acceleration with respect to t. So, for t to the power half, integrate this into respect to t, we have 4 t to the power 3 by 2 divided by 3 by 2, so plus c, that 8 by 3 t to the power 3 by 2 plus c. Now, when t is 0, v is 0. So we have 0 equal to c. So v equal to 8 by 3 t to the power 3 by 2 plus 0. Now, see, we have the expression for v to find the speed at equal to 9. When t is 9, you find v. That will give us the speed of the particle at equal to. So it is 72, this 72 meter per second. That's the speed of the particle when t equal to 9. That's part A. Now let's move on to the part B. Find the time after leaving O at which the speed and the distance traveled are numerically equal. That is V and S have same numerical value. Okay. So for that, you need to find the expression for S first. T, S is not given, so we have V in terms of T, integrate V in terms of T with respect to T to get the expression for S. So we integrate this one. We have 8 by 3 in times 2 to the power 5 by 2 divided by 5 by 2 plus 8. So S is 16 by 15 t to the power 5 by 2 plus k. Now remember, E 0, S is 0. So we have 0 equal to S. Now S is 15 by 15 to the power 5 by 2. Now we have to find the time at which the distance traveled is equal to the speed of the particle. So V equal to S. V is, where V is 8 by 3 to the power 3 by 2. S is 16 by 15 to the power 5 by 2. So we have, I take both sides, both come on the same side. It takes 16 by 15 comma, and the e to the power 3 by 2. We have here e to the power 5 by 2 minus 3 by 2, that's 1, minus 8 by 3 divided by 16 by 15, that is 8 divided by 3 divided by 16 by 15, we have 5 by 2. Yes. So, E is 5 by 2 seconds. Okay, that's the time at which the speed of the particle and the displacement are numerically equal. That's part B. Okay, that's the end of the question 3. Now let's move on to question number 4. Question 4 is this. A toy railway, a toy railway locomotive of mass 0.8 kg is towing a track of mass 0.4 kg on a straight horizontal track at a constant speed. So it is moving with constant speed. There is a constant resistance force of magnitude 0.2 Newton on the locomotive, but no resistance force on the track. So there is a light, rigid horizontal coupling connecting the locomotive and the track. Create the tension in the picture. Now, let's see the situation on a rough diagram first. Okay, the locomotive and the track both model as vertical. They're connected by a rigid light or rigid coupling, horizontal coupling, and there is resistance on L is 0.2 Newton, and they're moving with the speed v equal to 2 meter per second, and resistance on the poles is resistance on the track is 0, and there is tension from the coupling. See, acceleration is 0, so if you consider for track, we have resultant force is 0. Wait a minute. So, resultant force is 0 is T equal to RT. So T equal to 0 Newton. That's the tension when the locomotive and the track is moving at constant speed. Now you have to find the power produced by the locomotive engine. Remember, here there is a forward driving force produced by the locomotive of the locomotive's engine. So, and that driving force is called to P by V. Again, it is moving at constant speed, so acceleration is 0. So, G equal to P plus RL. And we have D equal to P by V. V is 2. Equal to 0 plus RL is zero point 0.2. So power is 2 into 0.2, 0.41. Okay, that's the power. Now, let's move on to the next part. In the next part, the power produced by the locomotive's engine is now changed to 1.2 watts. And in that case, find the magnitude of the tension in the coupling. At the instant, the locomotive begins to accelerate. Now, when the locomotive begins to accelerate, that means that the speed is 2 because it was initially moving with a speed 2 meters per second. When the power is suddenly changed to 1.2 watts, at that instant, still the speed is 2 meters per second and there will be acceleration. So in that case, we have, if we apply the formula, then for locomotive, Newton's second law, V by V minus T minus RA. And remember here T not be 0 equal to mass of the locomotive is 0.8. So we have 1.2 divided by 2 minus T minus RL 0.2 equal to 0.88. Okay. Then we have 0.4 minus T equal to 0.88. That's equation 1. Now for third, for T, we have T. We look at the diagram, T minus RT, T minus 0 equal to NA. And mass of the track is 0.4, 0.4 A. So T equal to 0.4 A. That's equation 2. Now add this equation. We have the acceleration 0.4 equal to 1.2 A. So A is 1 by 3 meter per second square. So T is 0.4 into 1 by 3, that's 2 by 15 Newton. Okay? That's the tension in the coupling. At the instant, the locomotive begins to accelerate. Okay, that's part C. I hope you clearly understand the explanation here, and if you still feel there is any confusion, please mention it in the comment section. I'll try to attend it as soon as possible. Okay, that's the end of question number 4. Now let's move on to question number 5. Okay, in the question 5, what we have here, the diagram shows a block D of mass 100 kg supported by two sloping struts, AD and BD. These are the two struts which is supporting the block. Each attached at an angle 45 degree to 6 points A and B respectively on a horizontal floor. Okay. The block is also held in place by a vertical rope 3D attached to a fixed point C on a horizontal ceiling. The tension in the rope is 500 Newton. The block rests in equilibrium and the magnitude of the force in each of the struts A, B, and BD. So let's see what it means. The block is supported by the strut, so the strut will provide a push to the block so that it doesn't fall below. So this push is, in fact, whenever strut or rod applies a push, we call it thrust. And thrust is inward, so this is the direction of thrust, but for all simplicity, let's show it here. Thrust provided by AG, and there will be thrust provided by BG. Okay, both of them making an angle of 45 degree with the horizon. 45 degree, that's 45 degree as well. Now, apart from these three forces, the thrust from the earth and the tension from the rope, 3D, there is also another force, that's the weight of the block, which is 100 kg in mass, so weight will be 100 G, that is 100 instead, that's 1000 Newton. These are the forces. And we need to find T thrust in the struct. Now, let's resolve it. Resolve it since there are two forces in two dimensions. So let's take this vertical plane, let's take the horizontal to the point D as x-axis and vertical to the point D as y-axis. In that case, component of TA, horizontal component, TA cos 45 because the angle with the horizontal is 45. That's why horizontal component is cos and the vertical component TA sin 45. And when you resolve TB, you get the same thing. Horizontal component TB cos 45 and vertical component is TB sin 45. Now, see, we have two horizontal components and they are balanced. So if we resolve horizontally, we have TA cos 45 equal to TB cos 45. So that means TA equal to TB. Both halves divided by the struts AD and BD are equal. Now, resolve vertically. If we resolve vertically, upward forces are TA sin 45 plus TB sin 45. Equal to and plus of another force. The tension from the spring that is 500 equal to force. So TA sin 45, remember TB also equal to TA, so TA sin 45 equal to 500. So we have TA equal to TB equal to 500 by 2 sin 45. So that's 250 times root 2 meter. If you keep it in exact form, or if you want to keep it in correct to 3SF, so in that case it will be 354. 354. You can keep the exact answer. You can also type it back to 3SF. Okay, that part A where we have found the language of force in each of the thirds which are equal and for the same equal to 250 root 2 or 854 Newton. Okay, that's part A. Now let's move on to part B. In part B, we have a horizontal force of magnitude F Newton is applied to the block in the direction parallel to B. And the value of F for which the magnitude of force in the strut AB is 0. So, in this scenario, we have a new force. Okay, what is the new force here? New force is there will be a horizontal force applied to the block and in the direction AB, the F, and you have to find the value of F for which tension in the strut AD is 0, that is TA is 0. If TA is 0, then TP obviously will not remain as 250 root 2, so this will have a new value. In that case, if you resolve vertically, you can find the new value of TB. Remember, TA is now 0, and then equate horizontally to find the value of F. So, in the next situation, if you resolve vertically, we have vertically upward TB sin 45 plus tension from the string CD 500 equal to weight, which is downwards. So QE equal to 500 divided by 545. So that is 500 root 2. Okay. Therefore, the angle remains same because of the reason. If we find the value A for which the magnitude of the force in the path AD is 0. A, the angle changes since both of them angle cannot change because both the straps are brought. So if one of the angle changes, the other strap will lock footing with the ground, which is not possible because it is fixed to the ground. And A, the other strap. So that's why the angle remains same. Now we know the new value of the charge in B, then spread horizontally, F equal to EB cos 45, so 500 root 2 cos 45, that will give you 500 Newton. So the value of F is 500 Newton. Okay, that part B. That's the end of this question. Now let's move on to the question number 6. In question 6, we have a block B of mass 2 kg. A block B of mass 2 kg lies on a rough inclined plane sloping at 30 degrees to the horizontal. A light rope inclined at an angle 20 degrees above the line of grid slope is attached to B. The tension in the rope is 3 Newton. There is a there is a friction force of 50 Newton acting on B. Is the diagram. Now the coefficient of friction between B and the plane is mu. So what we have here is that first of all, this is an equilibrium, right? Okay, great. Okay, in question 6, we have a block B of mass 2 kg lies on a rough inclined plane sloping at 30 degrees to the horizontal. A light rope inclined at 20 degrees above the line of grid slope is attached to B. The tension of the rope is 10 Newton, and there is a friction force of 8 Newton acting on B. The coefficient of friction between B and the plane is mu. Now, in part A, it is given that friction is 5 Newton and the acceleration of B of the plane is 1.2 Newton and the value of G. So, now we have the exact value of the friction, which is 5 Newton, and the block is moving up. So you have to find the value of T. Okay. In that case, to find the value of T, before that, we have to figure out what are the other forces acting on the block. Yes, forces we figure out is weight, the mass 2 kg, the weight is 200 Newton, and there is normal reaction. Okay. So if you resolve weight normal to the plane, it is 20 cos 30 because the vertical makes an angle of 30 degrees with the normal. So component of weight along the plane, down the plane, it is 20 sin 30. Now resolve T has a component along the plane up T cos 20 and normal to the plane is upward T sin 20. So if we have the acceleration, we have the friction. So if you apply the Newton's second law along the plane, and it is moving up the plane, So the resultant force is T cos 20 minus friction minus component of weight 20 sin 30 equal to M A, that's QA. So from this one, we have T equal to F plus 5 plus 10 20 sin 30 plus 2 into 1.2 divided by cos 20. That will give you the value of T. If we keep it correct to TSF, it is 18.5 Newton. Okay, that's the value of T. 18.5 tends to 18.5 Newton. Okay, now in part 2, you have to find the value of mu. We know the friction. Now we need to know the value of R to find mu. So if we resolve normal to the normal to the plane, then we have upward R plus T sin 20 equal to normal to the plane downward is 20 cos 30. So R is 20 cos 30 minus T sin 20. Don't substitute here because of T, which is rounded up to PSS at 18.5. Rather, use the value of T here, which is you have in your calculator, or you calculated T. Then, it is moving in motion, so friction is maximum, maximum friction is mu, so mu is F friction by R. F is I, R is friction. 20 cos 30 minus T sin 20 is substitute the more accurate value of T will get mu is equal to 0.455 correct to BSS. That's part 2. Now let's move on to part B. It is given instead that mu is 0.8 and T equal to 15. Determine whether B will move up the plane. To find that when T is 15 and mu is different, to whether B will move up the plane, that will depend entirely if T, whether T cos 20, T cos 20 is whether T cos 20 is more than these two forces, component of weight and the friction. This time, friction is not 5, rather we have to calculate. Okay, so let's first calculate friction. To calculate friction, we need to find the normal reaction. If we consider the normal to the plane, then we have R plus T sin 20 equal to downward, that is 20 component of weight 20 cos 30. Okay, so R is 20 cos 30 minus T, that's 15 sin 20. Okay, now friction is mu R, that is 0.8 in times 20 cos 30 minus 15 sin 20. Okay, now friction plus 20 sin 30, that is component of weight along the plane. Along the plane, downward forces is equal to sum of these 0.8 this is equal to 19.7521 blah, blah. And along the plane upward, P cos 20, that is 15 cos 20, this is obviously less than the forces down the plane, and this is equal to 14.0. 14.095. So obviously this is less. So T cos 20 is less than friction of component of weight. So T will not move off the plane. T lock. T will not move off the plane. Okay, as per B. Now, is there any further part? No. So let's move on to last question. Question 7. Here you see the diagram shows a smooth track which lies in a vertical plane. The section AB is the quarter circle of radius 1.8 meter with center O. The section BC is a horizontal straight line of length 70 meter. OB is perpendicular to BC. Okay, the section CFE is a straight line inclined at an angle theta above the horizontal. Now, a particle P of mass 0.5 kg is released from rest at A, and particle P collides with particle Q of mass 0.1 kg, which is raised at B. Okay. Immediately after the collision, speed of P is 4 meter per second. Here, speed of P is 4 meter per second. Then, obviously, the speed of Q will be more than that. I should also assume that P is moving horizontally when it collides with Q. So that speed of Q immediately after the collision is 10 meter per second. Okay. Although here they are asking for the speed of Q after the collision, but before that we have to find the speed of P just before the collision. And CP starts from this at A and moves slide down along the uh, segment AB, which is a quarter circle. Okay. And in this segment, this is smooth, so there is, we can consider the change in energy. If you consider work energy principle, we have GT loss equal to K gain, and since it is smooth, there is no friction. So GT loss equal to K gain. In that case, loss of GT is mass. Mass of P is 0.5 into 10 into the loss in height 1.8 equal to half into 0.5. That's the math. Half into m into v square. Remember, k gain half into m into v square minus u square. V is unknown here, e is 0 here. So we have this one. And then we have, if we cancel 0.5, if we divide both sides by 0.5, we have 36 equal to v square. So v is 6. That's the speed of p just before colliding with q. So p mass is 0.5 kg, moving with speed 6 meter per second just before hitting q, which is at rest, and mass of q is 0.1 kg. Okay, and after collision, he moves with speed 4 meter per second horizontally, obviously the same direction, since it moves horizontally in the same direction, and speed of q is unknown. Let's call it q. So if we apply conservation of linear momentum here, we have 0.5 sum of momentum before collision, 0.5 into 6 plus 0.1 into 0, and equal to 0.5. All of them are moving in the same direction, so all the velocity are positive. 0.1 into v, so v is 10. That's what the picture here. So v to 10 meters per second. So Okay, that's part A. Then in the next part, what we have to do when Q reaches C, C, where is C? At the end of the horizontal segment, that's C, 7 meters from B. And when Q reaches C, it collides with a particle R of mass 0.4 kg, which is at rest at C. These two particles collide. The combined particle comes instantaneously to rest at F. Where is F? That's C, that's F on the inclined plane. Now, you should assume that there is no instantaneous change in speed as the combined particle leaves, nor when it passes to C again as it turns down the slope. Okay. Given that the distance CF is 0.4, you have to find the value of theta. Okay, to find the value of theta first, we need to find the combined speed with Q and R move together. Okay, so in that case, since the VC surface is smooth, so Q will be moving with 10 meter per second when it hits up. So Q moving 10 meter per second, plus V for hitting R. R is at rest, 0.1 kg, zero point 0.4 kg. R is at rest. After collision, they collide to form a single particle of mass 0.5 kg, combined particle and move together. It V. You have to figure out the V. To find V, if you apply conservative law of momentum, sum of momentum before collision, 0.1 into 10 plus 0.4 into 0 equal to 0.5 into V. So V is 2 meter per second. So the compound particle moves with is, let's call it V3 combined 2 meter per second. Okay. And when the combined particle moves with 2 meter per second, it is zero. It comes instantaneously at F, which is 0.4 meter uh, from C, and it is on the inclined plane. And what is happening here? This inclined plane is also smooth, so there will be no friction. So what happens here? dP loss. It is no dP gain because it is gaining height. So there is dP gain and a loss. And remember, it comes instantaneously at S. So V is 0 at S. So we have dP gain equal to K loss because there is no K loss equal to dP gain. Why this one? Because you know the work energy principle from work energy principle, you can generalize work by external plus loss equal to gain plus work against resistance or friction. There is no external force involved in this situation here, so W work against external force is not here, and there is no friction, so there is also missing here. So we have only loss equal to gain, that's K loss equal to dP gain. Now K loss equal to half into 0.5 into loss. So U square, which is Q square minus V square is 0, and dP gain on inclined plane, dP loss or gain is measured. You can also calculate it as mg sine alpha times the distance it moves along the plane. So here we have zero point 0.5 into g, that's 5 sine, this angle is theta, so 0.5 sine, 0.5 into 10, that is 5 sine theta into the distance. So that's it. So we have, here we have half into zero point 0.5 into 4, that's 1, equal to 5 into 0.5, 2 sine theta, so sine theta equal to half, that is theta equal to tan inverse half, that is 30 degrees. That's the value of theta here, of B. Okay. Now let's move on to part C. Yes, there is another part. And the distance R from B at which C collides with the combined particle. Now the situation here is a bit tricky. Now you have to understand what is happening here. At the instant, P and Q collide after collision P moves to reach. At the instant P and Q collides here, P moves with speed 4 meter per second. P of BP4 and BQ is 10. From this moment, Q goes to C, then hits R of a combined particle, and moves together as a combined particle of to F, then returns back. And during this time, when we Q move from B to C, then C to F, and back as C, this time, P also moves towards C, and where it reaches. We have to figure it out. Now, let's find this step by step. The time taken by P to reach time taken by Q for Q. Time taken to reach B to C as the distance by speed, since it is moving in constant speed, S by V. Distance is 7, V 10, so this is 0.7 seconds. Now, then from A to F back to C. In this case, the Q combined with another particle, R, Q and R combined and move as a single particle with speed. How much is the speed? 2. 2 meter per second. So it will start moving with 2 meter per second up the plane from C to F. They start moving with the speed 2 meter per second. Not only Q, they move as a combined particle. Which is here and comes in instantaneous phase. Then it returns back since there is no friction. The acceleration is constant here. That is moving against gravity only. So when it returns back to C, it also moves with acceleration 2 meter per second because acceleration toward this segment CFC is constant. So we have final velocity -2, initial velocity +2, and we need to find the acceleration. What will be the acceleration here? While the particle is moving on this plane, it is moving against gravity, that is md sine theta, while whether it moves up or down. Let's consider the forward motion. Minus is considered the forward motion. Then we have minus mg sine theta equal to n. A, if we divide by n, we have minus g sine theta, that's minus 10 sine theta. Theta is 10, so it is minus 5 theta. Okay. Now you apply v equal to u plus at. V is -2, u is +2, a is -5 into t, that is the TFC, that term. So TCFC, this time is 4 by 5, 4 by 5, that is 0.8 seconds. So the time from B to C, then F, then C, the total time 0.7 plus 0.8, 1.5 seconds. That's the time to take. And by that time, how much distance we travel? That is S equal to, again, P is also moving with constant speed. So constant speed into time, that is speed is 4 times 1.5 to 6 meters. So if uh, when the combined particle returns at C, by that time P has already traveled 6 meters, so they are 1 meter apart. Okay, so by the time this is B, this is C, when the combined particle is here, combined particle here, moving with the speed 2 meter per second towards P. P is has already traveled 6 meters and it is moving with 4 meter per second speed. So they are moving towards each other. Let's say they will take further 10 seconds before they collide. This is 1 meter. So further after further 10 seconds they will collide, and in this further 10 seconds they travel E distance traveled by P plus distance traveled by Q, that will be equal to 1 meter. And distance traveled by P is speed into time, that's called T prime, plus distance traveled by Q, it is moving also at constant speed, so speed into time. Remember, the surface moves, so they will continue to move with constant speed. Only acceleration acts during while the combined particle was moving along the inclined plane. Now, T prime is 1 by 6. Now, we want to find the distance where they collide. This is the distance traveled by P, the distance traveled by Q. So, this is the point where they collide, and the distance of this from the distance of point of collision from B will be 6 plus distance traveled by T. So 6 plus distance traveled by P is 4 into T prime, 4 into 1 by 6, that's 6 to third meter. That's the distance where that's the point where they will collide. And this distance is equal to 6.6 to third. Okay, that's it. That's all. See, although it was a bit tricky, but if you analyze the situation step by step, you understand there is more of math B rather of mechanics. Only here on this inclined segment, you have to calculate the acceleration that is from mechanics. But from B, uh, we have to apply the formula only of dynamics. Okay. Okay, that's it. I hope you understand all the solution I have given to all the questions. If you think this video is useful to you, please give a like and subscribe to the channel. Hope to see you in the next video. Until then, Allah Hafiz. Assalamu alaikum.